Okay, guys, I just wanted to make a video to go over the Chapter 8 review for the test. So I'm going to go through all the problems and explain each of them. Feel free to go to whatever point in the video where you might have a question on the problem, so feel free to skip around. Okay, so starting with all of these first problems, all of these ones are factoring problems. So you'll notice they're all quadratics. They all have a highest exponent of 2. And if they don't, we have to consider something else because that's the method we learned. But the one thing I always come back to that you need to remember with factoring is you always have to check for a GCF first. So I'm going to look always and see if there's a common factor between the terms that I can remove first. So if I look at this first one right here, I see that it says n squared minus 4n minus 12. I know that there's not a common factor between these three terms. They don't have anything in common other than 1. So I'm going to jump right to my parentheses and factor this. So I'm thinking what times what is n squared? I know that's n times n. And then I need to think what could multiply to negative 12 but add together to be negative 4. So I'm thinking, well, 1 and 12, that's not going to make negative 4 when I add them. 2 and 6 could if one of them was negative. So if I need more negatives than positives, I need the 6 to be negative, the 2 to be positive. And if I check it, that becomes 2n when I multiply the insides. When I multiply the outsides, I get negative 6n. When I add these two together, that does make negative 4. So therefore, my correct factored form for this would be n plus 2 times n minus 6. Okay, for my next one here, again, I'm always checking for this GCF. And unfortunately, they all don't have an a in common, and there's no number other than 1 that's going to go into all three terms. 5 won't go into 18. So I'm going to break it down into two parentheses, two binomials. And now I need to think about the factors of the first term and the factors of the last term. Okay, so what times what is 5a squared if they both have an a? I know that's 5a times a. And that's my only option, which is nice. And then I'm thinking, what two numbers multiply to 35? Well, I could do 1 times 35. Or 2 doesn't go into 35, 3 doesn't, 4 doesn't. 5 does 7 times, 6 doesn't, and then we start getting repeats 7 and 5 again. So those are my only two factors of 35, which is nice because there's not a bunch of options. So generally, one rule of thumb, and I explained this in my other factoring video, is you don't want to start with 1 and 35 first. Because generally that's going to make the middle term be extremely big because you're multiplying a number by 35, which is going to be a lot. So I'm going to start with 5 and 7, and if that doesn't work, I can always come back to this. So I'm going to try 5 and 7 first. Here, my other rule comes into play. I cannot put the 5 here and the 7 here, because if I put the 5 here, then we have a common factor in the same parenthesis. Both of these numbers are divisible by 5, which is not allowed. So I know if I'm going to use 5 and 7, I can't put the 5 here. I have to put the 5 here and the 7 here. So now, if I check these, if I multiply my insides, I get 7a. If I multiply the outsides, I get 25a. And I'm thinking, is there any way I can make 18a with those two numbers? And I could if one of them was negative. And what's nice here is we do want them to multiply together to be a negative, which means one should be positive and one should be negative. So I need more positives than negatives. So I'm going to make my 25 positive and my 7 negative. And when I add those two together, negative 7 plus 25, I do get a positive 18. So I know that this is the correct factored form here. Whoops. So my final answer is 5a minus 7 times a plus 5. Okay, next one here. First thing I notice is these numbers are very large. So what I'm thinking here is there's probably a GCF among all the terms. So I start with my smallest number, 35 here, and I start thinking about, does 35 go into all three of these? And it does not. So I start thinking about other factors of 35, which is nice because I just had that, and these were the two factors. So it was 1 and 35 and 5 and 7. So I'm thinking, well, does 7 go into all of these? Because remember, I'm looking for the largest common factor, the greatest common factor, but 7 doesn't. So the biggest number that goes into all three of these is actually 5. So in order to remove that greatest common factor, I'm going to bring it out front, and then I'm going to divide each term by 5. When I do that, I get 7x squared. 195 divided by 5 would be 39x. And 90 divided by 5 would be 18. So now I'm not done. I'm always looking to factor this completely. So I'm now thinking, well, I have this. Is there any way I could break up that quadratic trinomial into two binomials? And we're going to try. So make sure you bring that greatest common factor out front still. And now let's see if we can factor this part. So I'm thinking, what times what is 7x squared? 7x times x. That's my only option, which is nice. And then I'm thinking, what can multiply to 18? Well, I know 1 times 18, 2 times 9, 3 times 6, 4 doesn't go into 18, 5 doesn't go into 18, and then 6 repeats. So those are my three options. Remember, I'm not going to start with 1 and 18. I could come back to that. So I'm going to start with 2 and 9. So if I put 2 here and 9 here, I have 2x when I multiply the insides. I have 63x, so I know that's way too big. So now let's think if I switch them. If I put a 9 here and a 2 here, that's 9x. 14x, also not going to work to make 39x. So I know 2 and 9 is not going to work. So then I'm going to try my 3 and 6. So if I do that, 3 times x is 3x. 7 times 6, or 7x times 6, sorry, is 42x. And I know I want them to multiply to a negative, so one must be positive, one must be negative. And this actually works because 42 and negative 3 makes positive 39. So I know I need negative 3 and positive 42. So there is my completely factored form. 5 times the quantity of 7x minus 3 times the quantity of x plus 6. Okay, my next one here, again, I'm always considering that greatest common factor. Unfortunately, 10 doesn't go into all three terms, 2 doesn't go into all three terms, and neither does 5. So I'm going to jump right away and start factoring this into two binomials if it's possible. So here's another example of where the a value, the first term, is composite, meaning that there are more than one option to multiply to 10. So I know I could do 10 times 1, or 10k times k, or I could do 5k times 2k. For 18, I could do 1 times 18, 2 times 9, 3 times 6, and those are all my factors. That's the same number we just dealt with. In this example, though, the nice part about this is that I know the two numbers have to multiply to a positive, and we're adding to make a negative. The only way you can multiply two numbers and get a positive and add to a negative is if both are negative. So that's one thing I know right off the bat. So remember a couple just tips to do these quicker. I want to try this pair first. I don't want to try the number in 1. I'll come back to that. And I don't want to try this first. I'm going to come back to that. I'm going to start with the 2 and the 9. So I'm going to try 5k and 2k first. And I'm going to try 2 and 9. Notice, if I put the 2 here, that's not going to work because then I'm going to have a common factor between these two in the same parenthesis, which is not allowed. So if I'm going to try this, I have to put the 2 here and the 9 here. When I check, 4K 45 is not going to make 27. So then I know that option is not going to work right there. So now I'm going to try my 3 and 6. If I put the 6 here, I notice I also have a common factor of 2, so not going to work. So if I'm going to use 3 and 6, the 6 has to go here and the 3 has to go here. So now I'm going to check it again. Multiply, negative 6 times 2k is negative 12k. 5k times negative 3 is negative 15k. So now when I check this, negative 12 plus negative 15 does make negative 27, so I know that is the correct answer here. Okay, moving forward with these, I'm now trying this t squared minus 9t minus 18. So I'm thinking about this, does it have a common factor? Unfortunately, this term only has a t and this one doesn't, so I can't take that out, so there's no common factor. So I'm going to try and do my factoring, just thinking about what factors multiply to this and add to this. So here's 18, same number as before. And I know that I need to multiply to a negative and add to a negative. So one must be positive and one must be negative. So I'm thinking, what two numbers can multiply to negative 18 and add to negative 9? Well, I know 1 and 18 are way off. That's not going to make negative 9, even if I make one of them negative. 2 and 9, if I think about that, that's not going to make negative 9 if I add them together and make one negative. So my only option is 3 and 6. The only way I can add them together and get negative 9 is if both of them were negative. The problem is, if I made both of them negative and I multiplied them, I would get positive 18, not negative 18. So this one ends up being not factorable because the only way I could use these numbers is if both were negative, and that's not going to give me negative 18 when I multiply them. So this is an example right here of something that is not factorable. Okay, next problem here. First thing I always check for is my greatest common factor. There's nothing that they have in common other than 1. So I do notice something about this problem. I notice that it's 2 terms, and I remember a method that we used called the difference of 2 squares. If you're subtracting 2 terms and they're both perfect squares, meaning you could take the square root of both of them and get whole numbers, I know I could break this down right away then. So how I do this is I take the square root of 16v squared, or I think about what times what is 16v squared if they're both exactly the same thing. And that would be 4v times 4v. And then I do the same thing. What's the square root of 1, which is 1. 1 times 1 is 1. How do I multiply to get a negative? 1 must be positive, 1 must be negative. And there is my factored form. Why is it only 2 terms? Because when I distribute it back out, if I checked it, you'll notice that the middle terms would cancel out. When I add these, I get 0. Okay, so taking a look at G here, this looks pretty similar to the last one, but again, I still always need to check for that greatest common factor first. So that's what I'm going to do here, is I'm going to check and see if there's a number that goes into 64 and also goes into 100. So I'm thinking about 64. I know 64 doesn't go into 100. 32 doesn't go into 100. 8 doesn't go into 100. So now I'm thinking about, could 4 go into 100? Because I know it goes into 64, and 4 does go into 100, and it does go into 64. And it's the biggest number that goes into both of them. So I'm going to take that GCF out front and divide both of them by 4. When I do 64x squared divided by 4, I get 16x squared. When I do negative 100 divided by 4, I get negative 25. So now I look at this and I need to make sure it's factored completely. So now I'm looking at the inside of the parentheses, and what I notice is 16 and 25 are both perfect squares. So I could actually further break this down by using the difference of squares method. What's the square root of 16x squared? Or what times what that's exactly the same gives me 16x squared? It would be 4x times 4x. What times what is 25? That's exactly the same, would be 5 times 5. And in order to multiply and get a negative, one must be positive, one must be negative. And same thing as the last example, if I checked, the middle terms would cancel out. That's the reason that there are only two terms there. So there's my final answer. That is factored completely. Okay, and my last factoring problem here. Another one that has some pretty big numbers, so I'm anticipating there's probably a greatest common factor among the three terms. So I'm thinking about 21, 108, and 108. And I'm thinking, well, would 21 go into 108? And unfortunately, it doesn't. So I'm thinking the next largest number with 21 would be 7. So would 7 go into 108? And it doesn't. So then the next largest number that goes into 21 is 3. So if I do 108 divided by 3, that actually does work out. But in this problem, I also have something else in common besides just that number. They all have x's. If they all have x's in common, I'm going to take the one out that has the smallest exponent, which is x to the first. So that becomes part of my greatest common factor. My greatest common factor is 3x. So I bring that out front, and I divide each term by 3x. When I do 21x cubed divided by 3x, I get 7x squared. When I divide negative 108x squared divided by 3x, I get negative 36x. And when I divide negative 108x divided by 3x, I notice the x's cancel, and negative 108 divided by 3 makes negative 36. So I'm almost done here, and now I need to think, can I keep factoring this? Is this factored completely? Well, I need to check and see if I could potentially factor this further. So I'm going to break that down and see if it works out. Don't forget, bring your GCF out front. So now I'm thinking, what times what is 7x squared? I know that's 7x times x, and that's my only option, which is nice. What multiplies to 36 would be 1 and 36, 2 and 18, 4 and 9. Whoops, I missed 3 and 12, sorry. And 6 and 6. So this one has quite a few options here. Remember, I'm not going to start with this 1 and 36. I'm going to start with my 2 and my 18. And if I put my 2 here and my 18 here, I know this is way too big if I do 7 times 18. If I flip them and do this, 18 times x would be 18x. If I do 7 times 2, that's 14x. So if I had 14 plus 18, I'm close, but I'm not there. That does not make negative 36. Also, I notice one of them would need to be negative, so that's not going to work out, unfortunately. So now I'm going to try my 3 and 12. Well, 7 times 12, way too big, not going to add to negative 36. So I'm going to try my 12 here and my 3 here. And I would get 12x and 21x. And I know that's not going to make negative 36 if one of them is negative. So that's not going to work. So now I'm trying 4 and 9. 7 times 9, you're starting to get the hang of this. That's way too big, so I'm going to try it the other way around. 9 times x is 9x. 7 times 4 is 28x. Unfortunately, that's not going to make negative 36. And now I'm trying my 6 and 6. So if I have 6 and 6 here, 6 times x is 6x. 7 times 6 is 42x. And now I'm like, well, if one of those is negative, I think I could potentially make this. I need more negatives than positives to make negative 36, so I need a negative 42x, and I need a positive 6x. And now when I add these two together, positive 6 plus negative 42, that does make negative 36. So therefore, this works, and that is my completely factored form right here, 3x times 7x plus 6 times x minus 6.